Good afternoon, everyone. My name is Cyril Concolato. I work for Netflix, and this is a joint presentation with Jan and Joe here in the audience. We want to talk about AVIF, so can I just run a quick show of hands? Who has heard of AVIF in this room? Wow, okay, cool. Then we can skip the presentation.
Keep going.
Okay. So no, I'll give a bit more details, probably that you don't know. What's happening?
Competence is definitely in my past, I think.
Yeah. Okay, so I want to give you a quick recap overview of the format itself, and then we'll give some results compression-wise and decoding-wise, and then some conclusions. So, as you know, AVIF is the AV1 image file format. It was released earlier this year, so as the abstract indicates, it's a specification that builds upon plenty of specifications, mainly for the file format coming from MPEG, and of course for the coding specification coming from AOM. So I want to give some details about these file format specifications. So you can view AVIF as being built on top of several technologies in terms of file format. And the underlying one is the ISO-based media file format that you probably are familiar with when you deal with MP4 files. That specification defines the core elements of the file. So, and the basic part is called the boxes. And in the case of AVIF, the box that is interesting for us is the meta box. That specification defines also all base concepts like how you do streaming, how you do data interleaving, how you do how you store a sequence of images in a video track, and what is important for AVIF is the notion of item, how you store one item, how you store one image. Based on that specification, there's another specification called HIF. So I put here IFF because it's called image file format, but the actual part of the MPEG specification to which it belongs is called the high efficiency image format. And sometimes it's confusing because people think that high efficiency image format is HEVC based, but actually that specification is codec agnostic. So you could store JPEG, AVC, HEVC, and in our case, AV1, right? And that specification is image specific. The core ISO-BMF specification does not have any image specific definitions. In this one, you have the definitions of what is a coded image versus a derived image. And in that case, it means a derived image is probably a transformed version of your image. So you apply a translation, you apply a rotation, a cropping, or a mirroring. That specification also defines different roles for different images. So you may have a master image, the image that is meant to be displayed in full resolution. And then you may have thumbnail images when you want to display them in your preview. Or you may have auxiliary images that are not meant to be displayed individually. But for example, if you have a transparency channel, that could be an auxiliary image. That specification also defines multi-layer images, how you process them. It defines how you can overlay multiple images together or make a larger image based on a grid of smaller images. It also defines how you associate metadata like EXIF or XMP to your image. Then on top of that, on top of HIF, you have MEF. And MEF is not a specification defining new technology. It's a specification constraining the existing technology. HIF is a big beast. It has plenty of tools in it, and you don't want to implement all of them, at least not for your every application. So MEF defines what we call structural constraints on top of HIF. And for example, self-containment is a really basic one. It says that the compressed pixels has to be in the same file as the metadata, not in a separate file. Or it gives limitations or constraints on the ratio between the size of the thumbnails and the size of the number of pixels in the thumbnails versus the number of pixels in the image. or it gives a constraint that if you're doing alpha, if you're doing a transparency channel, it has to be coded with the same codec than your base image. Right? That specification also defines application level constraints, because you might want to do animations in some applications. You might want to do storing. You might want to store burst of images in the same file, but you might not want to do that in some other cases. So if you want to store them in bursts, then you can follow these constraints. And finally, AVIF builds on top of these three specifications to describe how you store an AV1 keyframe inside the container file. And we define also two profiles, so basic and advanced, and they map to the lower profiles of AV1. We don't have yet in AVIF a profile for the 12-bit version of AV1, but it's not impossible. Just we didn't have requirements for that yet. So the capabilities of AVIF are really the capabilities of AV1 and stored in this container. So you can do pretty much all the things you want to do with an image, 8, 10, 12 bits. You can do lossless or not. You can do monochrome or multi-components. You can have any color space, either described by your ICC profile or by the typical codec-independent code points of MPEG. You can do different subsampling, and obviously, you heard about Netflix interest for HDR and film grain, so we care about these also for images. So I'm not sure you can see anything on the projector here. This is just to illustrate the differences that you could have in when encoding an image with a JPEG or JPEG 2000 or AVIF. Probably you don't see much. You tell me if you see anything. No. So we pushed a bit the boundaries here and went crazy here. I guess you can tell it's a bad image here, right? When you code it with JPEG 2000, it gets a lot better. And with the same ratio here, when you get to AVIF, it's slightly better. Probably I can toggle back and forth so that you see, but I'm not sure if you can. Like the hair of the woman or the skin tone is different. So less ringing artifacts here. We are very much interested in HDR images, and AVIF is a really great format for that. And maybe some of you are not familiar with our blog post that we made a year ago now. I encourage you to, again, go back to this post that describes what we do with HDR images in our UI. And there's a great tool called Vantage that you can download. It's an open source tool that allows you to visualize HDR images on an SDR display, highlighting which pixels are out of gamut, which pixels are out of overbright, and which are both. And it works recently with AVIF. In this case, this is you should see some pink pixels in the middle so the car is exploding, and these are overbright. The yellow lantern here, it means it's out of gamut. And so, yeah, you can play with that with this tool. And also I encourage you to follow the links to the additional AVIF images that we shared publicly. Many of them are HDR. So now you know what the formats can do, but how well can it do it? So we've tried to encode several images with AVIF and show you a result. What we did is we encoded multiple sets of images, one publicly available set of images, the Kodak image set, and then two sets of images internal to Netflix. And what we did is we encoded them multiple times to reach the predetermined VMAF values, 75, 85, and 95, and we're reporting these results here. So the first set we use is the Kodak test set, and here we're reporting the file size reduction compared to JPEG for 420 sampling. So as you can see, AVIF is consistently better at all these VMAF points, even better than HEIF. The same set at 444 sampling, still a lot better. Then we have a set of smaller resolution images that represent the images that we would use in our UI. Again, all these images are not HDR here. We're talking 8-bit. Again, AVIF is a lot better than the other formats here. 444, same thing. I should mention that we have, so the Kodak test set probably has, what, 400 or 500 images? Yeah, it's a pretty small one. This one, it's probably 1,300 images that we used. Yeah. And then the final set is larger images that we use for our billboard. So when you load the page with and you want to select the movie or the episode to play, these ones don't have text included in them. We overlay the text with graphics layer on top of it, so they're a bit different. And again, AVIF is quite better here than the other codecs, and same thing for 444. So that's pretty good. We're pretty happy with that. Now we wanted to understand how it would compare in terms of decoding. How fast could the AVIF be? Because when you're building a UI and you have several images in your UI, 10, 20, I don't know, you want it to be very fast. So we built this open source benchmark tool based on a tool that is called Colorist. So Colorist is a tool that allows you to convert or generate images, including HDR images. And Colorist benchmark is a benchmark that reuses this base tool. Comparing the decoding speed of libAVIF with David in it. Here I mentioned it's a 0.4.0 plus because it's a commit that's in between 0.4 and 0.5. We'll rerun the tests a bit later with the very latest David. JPEG uses a libJPEG Turbo, which is pretty fast for a JPEG decoder. J2K, we've used OpenJPEG, so we know it's not the fastest. We probably could have used Kakadu or even the HT J2K version of Kakadu, but we didn't have a chance yet. We'll do that again. And libWebP. So all our images, the total is probably 12,000 images, all 8 bits. Here, only reporting the 420 subsampling. And we have about 6 resolutions in total here. And I don't know if you can see it pretty well. So the left side is, can you see my, yeah, the left side here is AVIF. The middle side here is JPEG. The middle right, it's J2K, and the far right is WebP. And the times here are expressed in seconds, so 0.002 would be 20 milliseconds, and yeah, increasing resolutions. So as you can see, AVIF is not as good as a good old JPEG, as we could imagine, right? But it's doing a pretty good job, I think. What we noted when we look at the details of the decoding speed is that there's quite some variability in the decoding speed of David. And here, this morning, we had a report from YouTube that they had also this variability in decoding speed. But they were doing video sequences and they had multi-frame temporal units. Here, we're talking about single frame temporal unit and all keyframes, right? So again, there is also this variability. We want to understand it, maybe as was suggested, profiling the decoding to see what's taking time. So that's the third thing we noticed, some variability, and we also noticed it, the better the quality is, the longer it takes to decode. So there's this aspect that we didn't see, for example, in WebP. But yeah, we're pretty happy with these results. So if I remove the J2K part, that's taking increasing the scale here. You have more details here. So you can see that for low resolution, we're, I would say, maybe 1.5 to 2 times slower than JPEG, which is and on maximum, but on average, it's probably 1.5 maybe. Yeah. So So I want to give some conclusions here. You may not be aware that there are already plenty of AVIF tools out there. You have writers, so libavif, it's this C library that was developed at Netflix with the purpose to be lightweight and image friendly for the image community. So you can download it and use it in your applications. Colorist is a tool based on libavif to produce and read images. Of course, you can use AOMedia to encode your images, and then you can use tools like MP4Box, also another open source tool to package your images. And Windows has support for AVIF natively, so you can use Paint. Wow, that's something, right? Being able to use Paint to generate AVIF images. And then renderers, readers, you can again use libavif. You can use, so Chrome is actively integrating libavif. So you should soon have a build of Chrome that can render your AVIF images. Firefox, people can probably talk about it here, but I heard it's planned. Again, Windows has some support, and there are plenty of JavaScript shims, JavaScript libraries that you can use in your browsers to render AVIF. So as a summary, I would say that AVIF is to date the most compressed image format with an 8-bit decoding decoding speed slightly slower than legacy formats, but we're really looking forward for the 10-bit optimizations in David. But I heard they're in the pipe already, so we shouldn't have to wait for a long time. And AVIF integration is really ongoing in web tools and other image community tools. So you should expect large-scale deployments of AVIF soon. And yeah, start using it today. Thank you.
You have the microphone.
Hi, hello. Two quick questions. So when you presented the encoding comparison between AVIF and HEF and HIF, so my understanding correct that HIF means HEVC backed HIF?
Yes, in this case, yes.
Okay.
That's encoded with the HM here.
Okay, and the second question. So AVIF specification, is it defined on top of HEF or is it defined on top of MIAF?
So it's defined on top of MIAF, which itself is defined on top of it.
Right,
HIF,
right.
But it's defined on top of MIAF.
So it
tools,
basically carries over all the constraints that MIAF carries over.
Yeah, in
HEF.
particular, all the fancy tools that people don't need in HIF are not needed in AVIF.
But stuff like grid is still supported. So
grid is supported because, for example, if you want to reach resolutions that are very, very large, because of the decoding, because of the profile and level limitations in AV1 or in any other codec, the only way to build large-scale, large resolution images is to create a grid for that.
Yeah, right. Thank you.
I guess the question I have is, you do have AVI keyframe, AV1 keyframe there but what encoder did you use to produce the AV1 keyframe?
We used AOMedia, libAOM.
libAOM. So when you use libAOM for the format that's not 420, for example, 444, do you do anything special for the color channels?
You want to answer this one?
Anything special in terms of quantization for the UV channel? Or just use the default? Yeah, okay. That's just my question. Thank you.
First.
Just a question about implications for IMF delivery format. I know you could put JPEG 2000 frames inside IMF, which is the standard. But if AVIF is better, are you going to try and push to put AVIF frames inside the IMF standard?
There's no work at the moment to carry AV1 images in IMF. There's a need, why not? But currently the workflows and all the tools are well defined to work with J2K. So The reason
Okay.
we presented J2K here as a comparison is because when we started evaluating what technology could be used in UIs to display HDR images, the only good format for that was J2K, because good in many sense, like availability of tools and everything. And since then, the ecosystem has evolved, and we have AVIF. So when we thought initially we would use J2K for UI, and now the answer is clear: we'll use AVIF.
Okay, thanks.
One simple question. Tell me, what is BPG versus other format?
Okay, BPG is a wrapper around HEVC. So it's a very light wrapper.
So wouldn't that be the same as AVIF?
The codec part would be exactly the same. The container format would be very different. For example, HEIF can do combination of transparency and RGB channel. HEIF can do grid. HEIF can do rotation. These features are not in BPG. But yeah, if you care only for like storing a single image, you could go for BPG. But HEIF is a standard. HEIF is supported in many platforms. BPG is not a standard. It's only supported where you have it implemented.
But AVIF is better than that.
Sure, yeah. So if, sorry, let's go back here. The numbers we give here for HEIF would be very, very similar for BPG. So in terms of compression, yes, would be faster. It would be better, sorry.
So one suggestion is, if you're encoding with AOMenc, you may try to use super res mode equal to 4, which is the auto super res mode for images. So we have seen some advantages for very high complex images at very low bitrate.
What resolution would it start being useful?
Any resolution?
resolution?
Yeah.
Okay, thank you.
Thank you.
Anybody else? Okay, thanks, Cyril.
Thank you, Mr. Grange.